You might wonder what this man is doing with a fishing pole in the middle of the African savanna. He's actually looking for termites. Most commonly known as household pests, termites can also be ecosystem engineers that prevent desertification in vulnerable ecosystems. They do this by building mounds, which are their homes. These termite mounds make resources available to organisms around them.
The termites, because they eat all this dead vegetation, they break down all the nutrients, and so there's a lot more nutrients in the mound for the plants to use, and there's a lot more water because they create all this tunneling, so they also allow the water to infiltrate better and to spread better in the soil.
The mounds are arrayed in a specific pattern within dry landscapes, and this pattern could be playing an important role in combating desertification. The patterns form because of competition between termites.
They're very territorial. So you have these termite mounds with huge colonies, millions of workers, and they have kind of a central mound, and from there they forage out. And as they forage out, they whatever other termite they come across, they start to fight with it. So you start to form these territories, like a patchwork of territories. So you end up with colonies of roughly the same size that are pretty much organized like a hexagon, like hexagons, right? So like a bee's, how do you call that? Honeycomb. Thank you.
And this honeycomb pattern of mounds is actually really good for ecosystems. You can think of each mound as a little convenience store.
So if you were to build, supermarkets in Manhattan, you wouldn't build one in the center of Manhattan. You would probably, the best way to approach it would be to build a small one every few blocks so that everyone has better access. So that's kind of how the termite mounds are. They're making it such that resources are available within walking distance from every point in the savanna.
Plants do the same thing. They arrange themselves in patterns.
If you have a plant that does well in a certain location, its roots maintain water at the surface. So that makes it really good for other plants to also be there. Otherwise, all the water in a desert would just go and sink where the plants wouldn't be able to reach it.
But, as Professor Termites says, as plants thrive, their roots extend, sucking up more and more water. This creates a dry ring around the vegetation clump that inhibits growth.
So that's how you get these kinds of patterns. And you can see them from satellite images.
The termite mound patterns, on the other hand, are much harder to detect.
You would completely miss it unless you know how to look for it.
So the researchers had to get creative.
They tried drones, and they tried kites, and they tried complicated ways to take photos, and they were always missing it because they were always going a bit too high.
Because of the size of the termite mounds and local vegetation, the pattern is only visible from a certain distance, kind of like how you can't see the texture on a basketball until you're standing right next to it.
And eventually they tried this fishing pole, a telescopic fishing pole that's about 10 meters height, and from 10 meters height, it was just the perfect height to actually capture the whole pattern, and then we could quantify it.
Once they quantified it, using mathematical models, they figured out that the patterns caused by termite mounds hold together ecosystems when water is scarce. Without termite mounds, these places would become deserts. Desertification happens after a catastrophic shift, the sudden point at which all vegetation completely disappears. As climate change threatens to make some regions more arid, desertification is becoming a bigger concern. This research suggests that the climate models used to predict the effects of climate change don't capture the entire picture.
The whole story is more nuanced, and that whenever these models are made of climate change, they typically are at a very coarse levels. They should take into account other things like animals, especially ecosystem engineers, right? We know that's why we call them ecosystem engineers, because they modify their environment so dramatically. So something like termites may actually play an important role. Ecosystem engineers might actually be something that we need to consider. And the same goes for microbes and their interesting activities, all these like smaller scale activities that maybe haven't been integrated in climate models.